Okay, this is the Unit 3 Lesson 2 video. We're in Chapter 7, Section 2 out of the textbook, and this lesson is about solving exponential equations and inequalities. We're working on two content standards in this lesson, and the first one is create equations and inequalities in one variable and use them to solve problems. And our second one is for exponential models, express as a logarithm the solution to a times b to the ct power equals d, where a, c, and d are numbers, and the base, b, is either 2 or 10 or e. And then we will evaluate the logarithm using technology, presumably our calculator. Our mathematical practice to focus on in this lesson is reason abstractly and quantitatively. So in the last lesson we graphed exponential functions, and in this lesson we're going to solve exponential equations and exponential inequalities. We're looking at some new vocabulary terms. We're going to be talking about exponential equations, compound interest, and exponential inequalities. So our first concept for this lesson is the property of equality for exponential functions. So it says that if b is greater than 0 and b doesn't equal 1, then bx equals by if and only if x equals y. So this is only true when x equals y. And x equals y is true if b to the x equals b to the y. If and only if basically means you can read the equation from left. The left thing, if the left thing is true, then the right thing is true, and it means if the right thing is true, then the left thing is true. So for example, if 3 to the x equals 3 to the 5, then obviously x has to be 5. And if x equals 5, then 3 to the x has to be equal to 3 to the 5. Alright, so our first example, it says solve the equations 3 to the x power equals 9 to the 4th power. So what we're going to try to do in these kind of equations is to come up with the same base on each side of the equations. So we need to recognize first that 9 is the same as 3 squared. So we can rewrite 9 as 3 squared and 9 to the 4th as 3 squared to the 4th, which becomes 3 to the 8th, which means that x equals 8. So for part B, we're going to do the same kind of process, but it's a little bit more algebra involved this time. We see 2 to the 5x power equals 4 to the 2x minus 1 power. And we're going to try to get both of these in the base of 2, since 2 is the smaller number. So we need to recognize that 4 is 2 squared. So we're going to rewrite 4 as 2 squared and then distribute this 2 to the exponent. We get 4x minus 2. And then we just take the exponents and set them equal to each other and solve them as a basic algebra equation, and we get x equals negative 2. Alright, here's a check your progress problem for example 1. Pause the video as long as you need, and when you have your answer, go on to the next screen. And our answer for this one is choice B, 9. 4 to the 9th power is the same as 64 to the 3rd power. Part B, same thing, pause the video as long as you need, find the same base, and then solve the algebra equation from the exponents. And what we're going to see this time is that our answer is choice A, x equals 1. Alright, example 2, we're looking at a real-world example on population, and we're going to need to write an exponential function in order to solve this problem. So it says in 2000 the population of Phoenix was 1,321,045. By 2007 it was estimated at 1,512,986 people. Write an exponential function that could be used to model the population of Phoenix. Write x in terms of the number of years since 2000. So the first thing we need to think about is that the beginning of our timeline is going to be the year 2000, and so that's when x is 0, since that's been 0 years since the year 2000. And at that initial time, the population was 1,321,045. So that's going to be our y-intercept. And that's also our value of a. Then when x is 7, so 7 years later after 2000 will be the year 2007, the population has increased to this new number. So we're going to substitute these values into an exponential function to figure out the value of b. So let's look and see what that looks like. So we're starting with the basic exponential function of y equals a times b to the x. And our a is our initial value, our y is our final value, and our x, the exponent, is our time that's elapsed in this problem. So we have this equation set up. The first thing we're going to need to do is divide both sides by this 1,300,000 number, and we end up with 1.145, about, with chopping off some digits there. So that's approximately equal to b to the 7th power, and then we're going to take the 7th root of each side, and we get that b is approximately equal to 1.0196, which means, coincidentally, that the growth rate, if you move this decimal place over twice, is 1.96% growth. So our final equation that models the number of people in the city of Phoenix after some number of years is y equals 1,321,045 times 1.0196 to the x power. And remember that x is the number of years since the year 2000. Okay, part B. In 2000, the population of Phoenix, same setup. By 2007, same setup. We're going to predict the population of Phoenix in the year 2013. So we're going to use the model from part A, which was this equation right here. And this time, it's been 13 years since the initial year of 2000. So we're going to plug in 13 for x, and then just type that in your calculator, and you get about 1.7 million people living in Phoenix in the year 2013. Okay, we're going to jump to the check your progress problem. Same kind of setup for this. Read through the problem. Once you have your answer, go ahead and advance to the next screen, and we'll see what the answer is. Okay, the answer this time is D. The initial population was 9,426. If you find the growth rate, you should have gotten 1.0963, and we're doing to the x power. Now we're going to use that equation that we just found in part A to predict the population of Tisdale in 2012. So go ahead and look back at that equation and plug in whatever you would need to for the year 2012. When you have your answer, go on to the next screen. Okay, our answer this time is choice A. Our prediction for the population is 28,411. Okay, our next key concept for this lesson is the concept on compound interest. And the compound interest equation looks like this. It says the amount of money that you have in some account after some number of years is equal to P, which is the principal or the beginning amount that you put in the account, times 1 plus R over N. R is your rate of interest. N is the number of compounding periods each year. And this is multiplied or raised to the n times t power. T is time, n is, again, the number of compounding periods each year. So for example, if you see a problem where it says that we're compounding semi-annually, that means twice a year, so n would be 2. If we're compounding monthly, there's 12 months in a year, so n would be 12. They're always going to make sure they use some word in the problem to make it obvious what n is. But it's important that you read carefully so you can pick out what that amount is. So example 3 says an investment account pays 5.4% annual interest compounded quarterly. If $4,000 is placed in this account, find the balance after 8 years. So the first thing we need to think about is what are all our values of our variables. So we're going to be starting, we need to find the balance of the account after 8 years. We know the principal, the initial amount that we put in is $4,000. The rate, 5.4% converted to a decimal, is 0.054. N is 4 because we're compounding quarterly, and there's 4 quarters in a whole year. And T is 8 since we're finding the balance after 8 years. And so now just plugging those values into our equation, we get 4,000 times 1 plus 0.054 divided by 4 to the 4 times 8 power. And then you're just going to straight plug all that in the calculator, and you should get the answer of $6,143.56. Okay, let's do a check. Just to check this answer, we can put the equation in the initial calculator and find the x value of 8, just typing x equals 8 into your calculator, and it will show you 6,143 as the y value on the equation. Okay, so we're looking at a check your progress problem now for example 3. Same kind of setup. It says we have 4.6% interest compounded quarterly. We're putting in $6,050 initially, and we're finding the balance after 6 years. So pause the video when you have your answer, go on and check out the answer on the next screen. Okay, our answer this time is $7,960.43. Last thing we're going to talk about in this lesson is the inequalities for exponential functions. So it says if b is greater than 1, then b to the x power is greater than b to the y power, if and only if x is greater than y. And also b to the x is less than b to the y, if and only if x is less than 1. So for an example, if 2 to the x power is greater than 2 to the 6 power, that means x has to be greater than 6. And also, therefore, if x is greater than 6, then 2 to the x power would also be greater than 2 to the 6 power. So we're going to try to solve this equation for example 4 that says 5 to the 3 minus 2x power is greater than 1 over 625. So the first thing we want to do is look at this fraction 1 over 625 as 5 to some power, since we have 5 over on the left side of the inequality. And 625 is 5 to the 4th, so 1 over 625 would be 5 to the negative 4th power. So now we have this expression 3 minus 2x is greater than negative 4. Based on the bases being the same, we can just look at the exponents. So we're going to solve that inequality, solve for x, and we get x is less than 7 halves. Remember that every time we divide by a negative number, we're flipping the inequality sign over. And so our answer then is just x is any number less than 7 over 2, which is 3.5 if you prefer decimal values. Okay, last thing we're going to do is look at a check your progress problem for this example. 3 to the 4 minus 3x power is greater than 1 over 243. So pause the video when you have your answer, go on to the next screen. Alright, and for the last one, the answer is C. X can be any number less than 3. So that brings us to the end of the Unit 3 Lesson 2 video on solving exponential equations and inequalities.